Good morning, Ron. Hi.
Morning.
We reached a point when everything is implemented and we just need to run it. But
Okay, but it will not run.
exactly, because computer program is guilty unless
Yes,
proven otherwise.
yes.
And we wrote some code and we could have gone wrong in many places. So now we need to bring life to our code. And let's share the screen and see the code. Just a minute. Okay. So the code. This is the code. We always put a link to this notebook with all the code and the explanation in the description of the YouTube lesson. So it should be easy to find this notebook. First, let's run this.
What is this internet address? That's the address where you put it, where you put the code?
Yeah,
Okay.
in the lesson in YouTube, you have a link to this code.
Okay.
Exactly. And now I run everything in order for everything to be loaded to the computer memory and stuff. I also added a small drawing that summarizes what the main ideas. Let's go over it. So as you remember, we are trying to construct a classifier that distinguish a cat from a dog, and we're doing it by fitting a function, right? Our space is X, which represent images, right? That's why it belongs to R in dimension of 120,000 dimension, right? This is X. And Y belongs to R2 or to simplex of dimension 1, right? It's a
The verdict, correct or not?
binary distribution. What?
The verdict. It says
The label.
whether you're right or not.
Yeah, right. Whether it's a dog, it's a prediction whether it's a dog or a cat with a certain confidence level. Right? And the F is our attempt to approximate a function that approximates those points. Each point is a sample in our data set, right? This
And
is called
the function is really the coefficients, W.
The
It's
function
determined by
is
it. I know it's not precisely, but
the function is determined by the coefficient, right?
and you're
But
looking
it's
for the
not the
coefficient.
coefficient. It's a function.
You're looking for the coefficient.
Yeah, I'm looking for the right coefficient for the function to approximate the samples good, right? And the criteria of how good is the approximation of F is called the loss function, which measures the distance of this function from the set of samples, right? Okay, and this is the explicit definition of the function, right? Softmax of W, which is a set of parameters, and X, which is a representation of the image, right? And the loss function, with respect to our data set, we call it also a cloud of points, this data set. For each W, we compute the average distance, and the distance is measured by cross entropy, this measure.
Yes, I still haven't understood why you're using cross entropy rather than just Euclidean distance or any measure of distance. You like, somebody likes.
Yeah, that's a good point. First, we are trying to measure a distance between two probabilities, right? Not between because Y here represent a binary probability, and you want to measure a distance between two probabilities.
Yes.
Euclidean distance between two vectors, and it's, it's not really just vector in R2, it's actually in the simplex of dimension 1, right?
Yes.
It's constrained.
Means the sum is 1. The sum of the elements is 1. Yes. Okay.
Yeah, exactly. So a
So
priori,
I believe you that people have
yeah,
thought about it and
first,
decided that.
yeah, I can say from experience, it turned out to be a good measure. But without knowing everything, it's not clear that Euclidean distance should be the right thing to do, right?
Yes.
Okay. Yeah, it was proven to be a good measure. And when you learn information theory, it kind of makes sense, but we didn't get really into it. We talked a little bit about redundancy measure and stuff like that, remember?
Forget. Yes. Okay.
Okay.
Redundancy. Okay.
Yeah, we talked about compression, about entropy, about
Okay.
cross entropy, which is like a redundancy measure, but it was a long time ago. Okay, so this is the loss function. But by the way, nothing is like written on the rock here, so you can change stuff and it might work even better.
Okay.
And the training is actually just a gradient descent on the loss, right? So
Descent,
we
you
are,
have to have an S after the C. This
pardon?
is descent. What you wrote is gradient descent, which means Hagun.
Right. I have a
S after the C.
yeah, right. But
Okay.
I cannot write it here. Yeah, I have a typing mistake. So the W is what we are playing with. We're looking for the best W, and the measure is the loss. So we are doing a gradient descent on, we're moving on the space of W in order to find a minimum loss, right? Okay. And this is the update rule of of the weight. Like the weight ij of the matrix is just updated using the the corresponding element in the gradient multiplied by LR, which
Right.
is
It's the gradient of the W's or the gradient of the loss function. Wrote delta, the gradient of some W.
the gradient of, it's the gradient of the right.
Gradient.
Yeah.
You want
It's
to
a
minimize the
mistake
loss
here.
function.
So another mistake, I should fix it. It's actually the derivative of the loss in respect to, It's a mistake. It's not gradient of W, it's gradient of loss with respect to this ij.
Yes.
Thank you for correcting me. I will change it. Yeah, right, exactly. Okay, so this is what we did, and we wrote many functions that implement it. Extract XY was just converting the data set into matrices, but this is the implementation of the F function. This is the implementation of the loss function. This is an implementation of numerical calculation of the gradient of the loss. And this is the main function, which is the training, which is actually implements the gradient descent. And here is the update rule. Okay?
So train already includes the steps, namely it does many steps. Train is the result of the entire process.
Exactly. We have a for loop. We call it epochs.
Yeah.
So each step we have an update rule, and we hope to get better in this process. So now all we need to do is try to run it and hope for the best, but be modest about it, right? So in order to run it, all I should write is train ds, right? ds is
You
our
have a
data.
typo there.
Pardon?
You have a typo in train.
Ah, right. Thanks. That's why I have this red. Okay. No? Yeah, this is correct. What do you? What is your prediction? Will it run?
You tell me not.
No way.
My computer programs never run. Well, that was 40 years ago, but
I'm still human. It will not run. Okay, let's see. What happened here? A value error. Operand could not be broadcast together with shape. It said it has a 2 by 200. What is 200? Do you remember?
the number of samples is
Exactly. Yeah. 200 is the number of
You call it
samples.
K, if I remember correctly, right?
Yeah, right. We call it K. And what is 120,000?
That's the length of the vectors.
Yeah, which represent images, right?
The axis, yes.
Okay, so we have, you see here, it says in what line of code it complains. So it
I must
says,
say that programs have progressed since the last time I saw them 40 years ago. When I programmed, it was just say there is an error. You go find it.
I think we've come a long way in the usability of programming. Nowadays, interpreters and compiler are much more informative in what you did wrong, which saves you so much hassle. Yeah, it was used to be such an awful work to be a
Frustration,
programmer.
yeah. One prolonged
Pardon?
frustration. It was one prolonged frustration.
Yeah, it's still a frustration, but a less big one.
Okay.
Okay, so what it actually tells me that I multiplied matrices with mismatched dimensions. And what function are we dealing with? The loss function. So let's go to the loss function and try to figure out why. We did a mistake there. Here is the loss function. You remember what x and y represent?
Yes, okay. X is the picture.
Yeah, but
120,000
right,
X.
but big capital X is not just one picture. Remember, it's a matrices of all the pictures, right?
200 by 120,000. Yeah, okay.
The dimension of X, it should be 120,000 on 200.
Yes, okay.
Okay. And what is Y? What is the dimension of Y, you think?
2 times 200.
Exactly. 2 times 200. And W is the weight matrix. And what did I did here? I forgot something. You see, I forgot something. Let's go to the definition of loss. We have the definition of loss here. Definition of loss is H of F, right? We first, why it's H of F? Because first we calculate the value of F, and then we measure the distance between the F and the Y of the sample. So this is actually a distance between Yi and the F of XY. But I forgot to write F here, so I need to add it, right? It doesn't make sense. Let's add it. So I will write F equals, what should I do? I should use my definition of X, F, W X. Now F is the matrix of all the F activations on all X images. I have an indentation issue here, just a minute. And here, this should be of F. What we did here, I will just want to remind you, it's cross entropy.
So log 2 of F is a vector, actually, because F is a vector.
Pardon?
What is F, the capital F? It
A
is
capital
a
F,
200.
let's write the dimension. A capital F should be dimension of 2 by 200.
Yes.
It's
log 2
all
F,
the predictions. It's all the prediction of F.
yeah. So log 2 of F is the same dimension, right?
Exactly, because it's element-wise. It just log in the base of 2 element-wise of F.
Okay.
And why do we multiply it by Y? Because that's the definition of cross entropy, and the minus also come from the definition of cross entropy, and also the sum. Okay, so I'm updating this function now. So we correct it, and let's try to run it again. Will it run? No way.
Of course not. What do you mean?
Okay, now we have something completely different. We corrected the problem before. We have overflow encounter in exponent.
It doesn't like exponent of large numbers. What?
I'm sorry?
It doesn't like exponents of large numbers. That's what it's saying.
Exactly. Yeah, it's like, let's look where do we use exponent? We use it here. Why do we use it?
Smoothing. How do you call it? What was it?
Yeah, softmax, exactly. Softmax. We wanted a relaxed version of argmax. We wanted like
so just cut it by, I mean, add minimum between this exponent and 2 millions. I don't know how much.
I think you're heading to the right direction, but let's first understand why we have this problem. So the problem is here is F, and I want to isolate it. I don't want to mess with very complicated stuff. So let's isolate the problem, understand it, and then fix it. Okay, so let's instead of let's put this in a comment and do something simpler. First, we'll do it by hand. I'll show you. We'll take those two lines here. I want to understand the problem exactly. So what do I do here? I'm using the same initialization I'm using in train. So first I converted the data set to XY matrices. I initialized a parameter, a matrix, and then I just want to run F. So let's do something like that. F equals F of what should be the order of the parameters. F, where do I have F? F should be W and X. Okay, so W and X. And let's just print the result and see if we see something. Let's print F shape. You remember what shape means?
No.
Shape is the dimension of the matrix.
Okay.
I want to see if the dimensions are correct. And let's print F itself. Let's see what happened. And I put the train in a comment, so I'm actually running something much simpler. Wow, what happened? Well, it's kind of big, but first, the dimension is 2 by 200. Does that make sense?
F, yes. F is what,
Yes,
that's
it
what F
makes
is.
sense. 2 by 200, it's the matrix of prediction. It should be a distribution, right? Probabilities.
Yes.
What is none? Do you have any idea what none means?
It's very small, nano. No, I don't know what is none.
None is not a number.
Aha,
So
okay.
maybe I divided by 0. I did some wrong arithmetic calculation. It's an error. We already spotted an error. What does that mean? That's also kind of strange. What number is that? It's a, a floating point representation with exponent and a number. So it's 1 with exponent 0.
Where is the exponent 0?
Yeah, it's you never have that. It's a 1 actually, but that's kind of weird. But what is this is a small number. So something went wrong here, right? Something went
What
wrong.
is e to the minus 001? What is 001? It's 0.01 or?
It's just -1, I think. So it's this is a representation of half, but it's just a half. But no, not a half.
1/5.
I'm not sure actually. It's kind
That's
of
very strange.
weird. -1 is like tenths. So 5 multiplied by tenths, it's a half. But let's look at
It's e to the -1. What is, it's
E,
exponent.
E
It's not e,
represent
that's natural, yes.
E
Exponent.
represent exponent of 10.
So yes,
It's
so
a
it's
decimal.
1,000.
Pardon?
Or, no, so I don't understand what it e to the -1, so it's always
Yes,
1/10. That doesn't make sense.
but let's see. I want to look at something went really bad
Absolutely
here.
wrong. Yes.
The not a number already said something went wrong. And we are dealing with some very basic operation. So let's see the implementation of F. Let's copy the implementation of F and do it by hand and see what happened here. Where did we go wrong? So instead of running F like I did before, I will do it explicitly. You see what I do here? I do the, you remember this sign, what it means?
No, you told me last time, but I forget.
This is matrix multiplication in,
Yeah,
yeah, it's just W by X. That's a fair. So we have two, let's do it like that. Sorry, F equals. So first we do a linear operation, W multiplied by X. Let's delete the dimension. Let's delete that. And then this is actually the softmax part, right?
Yes, yes.
Okay.
I hope you got it right. I mean, some x over sum of x. Well, you know
Yeah.
you know the.
You want to talk about this operation here, why we did it?
Oh, it's clear. I mean, this is normalization.
Yeah, it's normalization, but it's not entirely clear in terms of dimension because, EXP is actually, I will write it down. EXP, sorry, it's, sorry, It's 2 by 200, and I'm dividing it by a vector of 1 to 200. You see, there should be mismatched dimension. You understand? The sum is over the
It's one
columns.
only, yes, yes, okay.
So how did it let me make this division that has a mismatch dimension? This is called in this library a broadcasting. It actually copying and make duplication. It just take care of it. It makes it like twice, like 2 lines. So
You want
it's
to
actually,
divide, yes, you want to divide
pardon?
each of the components. So there are 2 components in each
Yeah,
column. You want to divide each of them
two
by.
lines, 2 identical lines, like this things
Uh-huh.
here, which is exactly what we need. By the way, this division is element-wise division of
Yes,
matrices.
yes, I understand.
Okay. So here we have no problem, but I want to see
Tell me something.
how.
What is the sharp sign? Does it mean it's a comment?
It's just a comment.
Comment, yes.
It is ignored by the computer.
Yes.
Okay. So let's put all this in a comment. It will ignore it. I just want to see the first stage, the logit, and see if everything is okay here. So logit, first I want to see the shape, and then I want to see the content.
Remind me
Let's see.
what is logit?
Logit is the name I gave the linear
Okay, that's a
operation.
definition of logit. Okay.
Yeah. Let's see. Okay, 0.
It
What
doesn't
is
like
this?
you.
Okay, these are numbers. Actually, okay. So the dimension is the same. You see this number here?
Horrible numbers. Where did you get them?
Yeah. So this is only after the linear operation. It seems, I think, logical, but think of this number. E to the power of this number will
It's huge.
be huge, right? Let's instead of printing the content of logit, let's ask him about the max of it. I will say NP max. You remember what NP stands for?
That's some library, no? What is it?
Exactly, that's a NumPy library, and I'm using a max of this library, which works on matrices.
Okay.
So now I will print the maximum element of logit, okay? I'm running it. Wow. Can you imagine e to the power of this number?
I
So
can.
clearly we have a problem. Houston. So what let's ask.
1 minute. I thought that
Yeah,
there were probability vectors that you were working with. The
pardon?
sum is 1. No, how can you get in such a huge number? So you want.
No, this huge number is only after the linear operation. It's before the normalization.
Okay, yes, yes, yes.
W, yeah, X is just numbers that represent an image, and
Yeah.
we multiply it by parameters. We know nothing about these numbers. Okay, so clearly we have a numerical problem with the softmax function. Also, I want to point out another thing, that after let's see something. Look at the loss function.
Mm.
After f, we have a normalization, which is e to the power. And just after that, we are doing log, which is the reverse operation. We do e to the power and then log, right? So we might want to do something simpler here to make it. You understand what I'm saying?
I forget where do you put the log? Log is the entropy function, but okay, I don't know. So you're saying that the y's, why do you put the log on? The log is on
The
x or on
log,
y?
the log come from the cross
On f or
entropy.
on y? On f.
Yeah, it's log of f. It's
Log of f,
come
or
from the definition of cross entropy.
yes. So
And
you're
f,
saying that
and f is the result of f is after softmax, which is
yeah.
kind of the reverse operation, right?
Yes.
So I think it's we understand we have a problem. We understand what is the problem. We need to think of a solution. So it's a good place to stop, I think.
Okay. I'm happy. Okay.
Okay. So
But,
thank you and see you
yeah.
next time.
Yes. Bye.
Okay, goodbye. Bye-bye.